Hurricanes, these swirling storms are a spectacle of nature's power. Imagine winds howling at incredible speeds, torrential rains flooding the land, and waves crashing onto the shores with immense force. That's the fury of a hurricane, a force to be reckoned with. But have you ever wondered how these monstrous storms are born from the tranquility of tropical waters? The science behind hurricane formation is as fascinating as the storms themselves. It's a delicate dance of atmospheric conditions, a recipe that requires just the right ingredients to cook up a storm of such epic proportions. Let's dive into the heart of hurricane formation and unravel the mysteries of these swirling giants. Imagine a vast expanse of warm ocean water basking under the tropical sun. This is our first ingredient, the fuel that powers the hurricane engine. As the sun's rays beat down on the ocean, water evaporates, rising into the air like steam from a boiling pot. This warm, moist air is the lifeblood of a hurricane, providing the energy it needs to grow and intensify. But warm water alone isn't enough. We need low air pressure above the ocean's surface, creating an area where the rising warm air can converge. Think of it as a vacuum cleaner sucking the warm, moist air upwards. As this air rises, it cools and condenses, forming thunderclouds that release even more heat, further fueling the storm's engine. Finally, we need the right wind patterns to get the hurricane spinning. Gentle winds near the ocean surface start the process, pushing the rising air and giving it a slight rotation. As the storm develops, these winds intensify, whipping the hurricane into a frenzy. Now, here's where things get really interesting. As the Earth spins on its axis, it creates an apparent force called the Coriolis effect. This force acts on moving objects like our developing hurricane, causing them to curve as they travel. In the northern hemisphere, this curvature is to the right, while in the southern hemisphere, it's to the left. The Coriolis effect plays a crucial role in giving hurricanes their spin, as the warm air rises and rushes towards the low-pressure center. The Coriolis effect causes it to curve, creating the characteristic spiral pattern we see in hurricanes. This spinning motion further intensifies the storm, drawing in more warm, moist air and increasing its wind speeds. From disturbance to destruction, the stages unfold. The birth of a hurricane is a gradual process, a transformation from a mere ripple in the atmosphere to a raging monster. It all starts with a tropical disturbance, an area of disorganized thunderstorms that forms over warm ocean waters. These disturbances are quite common, but only a small fraction of them develop into hurricanes. If conditions are favorable, a tropical disturbance can intensify into a tropical depression characterized by a more organized circulation of winds and wind speeds of up to 38 miles per hour. As the storm gathers strength, it becomes a tropical storm with wind speeds between 39 and 73 miles per hour. At this stage, the storm is given a name and its winds are strong enough to cause minor damage. Finally, when wind speeds reach 74 miles per hour or more, the storm is classified as a hurricane. Hurricanes are categorized into 5 categories based on their wind speed, with Category 5 hurricanes being the most intense and destructive, capable of causing catastrophic damage. The eye of the storm, a center of tranquility. Amidst the chaos and destruction of a hurricane lies a place of surprising calm, the eye. This central region of the hurricane is characterized by calm winds, clear skies, and strangely warm temperatures. The eye is surrounded by the eyewall, a ring of towering thunderstorms where the most intense winds and heaviest rainfall occur. The contrast between the tranquility of the eye and the fury of the eyewall is one of the most striking features of a hurricane. As the hurricane passes overhead, it might seem like the storm has passed, only for the winds and rain to return with even greater ferocity once the eyewall arrives. A legacy of power and respect. Hurricanes are a testament to the immense power of nature, a force that can reshape coastlines, flood cities, and leave a trail of destruction in its wake. Understanding how these storms form is crucial for predicting their path, intensity, and potential impact. While we can't prevent hurricanes, we can learn to respect their power and prepare for their arrival. By studying these swirling giants, we gain a deeper appreciation for the forces that shape our planet and the importance of being prepared for nature's awe-inspiring displays of power.